On May 1st, 2006, after 27 months of planning and construction, the Hotel InterContinental Resort and Talasso Spa opened to guests on the French Polynesian island of Bora Bora. Consisting of 80 spacious villas built over the turquoise-colored lagoon, this luxurious eco-hotel boasts the first Talasso Spa in the Southern Hemisphere and is the very first hotel in the world to be entirely air-conditioned with cold water drawn from the ocean depths. The deep ocean water is of simply astonishing purity and provides a veritable fountain of regeneration for combating the fatigue and stress of modern life at the hotel's deep ocean Talasso Spa. The Tahiti Beachcomber Corporation, which developed the hotel, is already well known in the Polynesian hospitality business as owner of 3 other highly acclaimed resorts operated under the InterContinental banner on the islands of Tahiti, Moorea, and Bora Bora.
Hotels are very large consumers of energy, and especially in the tropics where we use a lot of air conditioning, and in an insular economy such as French Polynesia's, energy has a very high cost. So naturally, when we decided to build a new hotel in Bora Bora, we started looking for alternative sources of energy.
Richard Bailey worked with the notorious actor and earth defender Marlon Brando for several years on a plan to build an eco-resort on the actor's private atoll, Tetiaroa. In the end, he took up Brando's suggestion that deep sea water could be used as an alternative energy source for air conditioning and has applied the idea to his company's new property in Bora Bora. First, a hotel in a tropical climate has a large year-round demand for cold, both for air conditioning and cold storage of perishable goods. Second, the site has access to deep ocean water in close proximity. And finally, French Polynesia's insular economy results in a very high unit cost of electricity. Enter Dr. John Craven, a pioneer in all aspects of deep ocean water. His Hawaii-based nonprofit Common Heritage Corporation has been dedicated since the 1970s to the study of ocean-based thermal energy and other uses of deep ocean water.
If we wanted to air condition a building, we could do it one of 2 ways. We could take OTEC electricity, use OTEC electricity for ordinary air conditioning, and air condition the building, or we could take the deep ocean water, run it through a little heat exchange, put a fan behind it, and cool it with the cold of the deep ocean water. We found out that the energy difference between those 2 ways of approaching is 100 to 1.
The process is simple. Cold seawater from a depth of 3,000 feet is pumped through a titanium thermal exchanger, where the cold is transmitted into a closed freshwater circuit. The fresh water then carries the cold throughout the hotel, supplying air conditioning and refrigeration to the hotel villas, the restaurants, the kitchens, the Talasso Spa, and the staff housing as well. A mere pump and thermal exchanger have replaced the bulky, expensive, noisy, and inefficient compressors of old. The thermal exchanger functions like a large radiator, transmitting cold from one medium, seawater, into another, freshwater. It is comprised of 200 titanium plates squeezed together into a sort of sealed sandwich. The cold seawater circulates on one side of each plate, transmitting the cold into, but without ever touching, the fresh water on the other side of the plate. Titanium is an excellent thermal conductor and is absolutely non-corrodable. The InterContinental Resort and Talasso Spa Bora Bora is the first true 21st century eco-resort. In perfect harmony with its environment, it represents a significant step forward in environmentally responsible tourism and provides concrete evidence that sustainable development can also save money, reduce maintenance, and even yield handsome returns. The seawater air conditioning system is quiet, free of ozone, depleting chlorofluorocarbons, or CFCs, has no impact whatsoever on the environment, is absolutely clean, and represents an energy saving equal to 90% of the electricity that would be used by the hotel with a conventional air conditioning system. In the case of the new InterContinental Hotel in Bora Bora, this is the equivalent of approximately 2.5 million liters of fuel oil less per year imported to French Polynesia. As work continues on the hotel site, the 2,400-meter pipe is constructed in 5 sections. They are assembled very carefully using heat fusion welding technology to ensure maximum structural integrity and longevity of the pipe under the tremendous pressure of the ocean depths. At the same time, exploration is underway along the ocean floor to determine the best path for the pipe. Sonar and photosynthesis technology are used to survey the depths and identify potential obstacles. Remote-controlled robotic cameras assist in this analysis. This homework will ensure that the pipe comes to rest in the best possible position and that it will be safe from the elements, underwater turbulence, and surface weather events such as hurricanes. Another technical innovation is the manner in which the seawater is returned to the ocean. On exiting the heat exchanger, the seawater, partially depleted of its coldness, flows to the ocean in the annular space of a large concentric pipe, which envelops the seawater intake pipe down to a depth of 150 feet, providing additional thermal insulation for the arriving water from the depths as it passes the warmer shallows on its way to the surface. The 5 sections, once completed, are assembled in the lagoon, then towed to the point of immersion. First, the pipe is connected at the reef. It is then gradually filled with water from the surface until it comes to rest at a precisely predetermined location on the bottom. Cement weights anchor the pipe to the bottom at exact locations. The immersion procedure occurs at night because the ocean is calmer. Once the pieces are attached and connected as planned, technicians go on one last dive to make sure all is okay. Tests are good to go. Pumps are switched on, the primary circuit pressurized. The seawater meets the titanium heat exchanger at a temperature of 42 degrees Fahrenheit. Time now for the secondary circuit and for the first test of the climate control system. The system functions as expected, even exceeding its theoretical thermal efficiency. Deep ocean water has been protected from atmospheric pollution for thousands of years. It is perhaps the purest source of water in the world. It is therefore ideal for the remineralizing treatments that are the guiding principle of thalassotherapy. These exceptional properties of deep ocean water are fully and exclusively offered to the pleasure of visitors at the Deep Ocean Thalasso Spa, open since September 1st, 2006, in the heart of the resort. Guests have a variety of thalasso treatments to choose from, and against a rich backdrop of indigenous woods, color-rich stones and corals, visitors are instantly transported to a world of therapeutic well-being, comfort, and relaxation.
Well, we're extremely satisfied with the results. What we find is that the capacity is much greater than we anticipated. The water is colder than we expected, so we have excess capacity. The guests are extremely happy with the result. And of course, our lower electricity consumption is very satisfactory.
I think it's going to be working for a long time for Dick Bailey and for the Beachcomber Resort there and the Beachcomber Resorts around the world. I think it's a technology that will be used by many other smart people.
Tahiti has found it. They've now installed this pipe, and we're going out to look at it because we know we want to put this out as an exemplar of what ought to be part of the evolutionary path which brings environmentally sustainable habitats to all of the world's island nations.
The InterContinental Resort and Thalasso Spa in Bora Bora has demonstrated that sustainable development and responsible tourism can be more than vain concepts. In the hospitality world of tomorrow, they must be guiding principles.